All right, guys, I'm going to do those extra examples. Finding the area of regular polygons using half apothem times perimeter from page 113 in our notebook that we didn't do in class. So, sometimes I feel like when you don't have a picture like this, it can be a little bit trickier, but I don't ever draw the full shape. So like for this one here, find the area of a regular decagon with an apothem of 6 feet. I'm not drawing that whole decagon. I can't. All I'm drawing is our little baby right triangle. And so normally I draw it kind of like this. And people ask me in the past, like, why do I make these two sides like dashed lines and the bottom one not? These lines I always make dashed because they're not true lines of the shape, and then this one is actually part of the shape, so I feel like in my brain it kind of helps me to remember that. So in our little baby right triangle, this is my apothem, here's my half side, and this is my radius. And then we're going to label what they tell us, and we're probably going to have to find that top central angle. So they told me the apothem is 6 feet, so that's kind of nice because I have half of the information that I need, but even if I only have half, I still need to find my top angle. So we're doing 360 divided by the number of sides, so 10, so that's 36 degrees, and then we need to split it in half again because my apothem splits the central angle in half, so 18 degrees. And then, based on whatever angle you get there, you're either using a special right triangle thing, which sadly not, or you're having to use a trig thing. Now, what we also noticed up here is whenever I have to find only one or the other, I always use tangent. So we have to find our half side. And because I have the apothem, I'm definitely going to use tangent. So we'll do tangent of our angle equals opposite of that angle. So that is my unknown. I can call it x over the adjacent side, which is the apothem, so 6. Now, whenever my unknown is on top here, we're just going to multiply that number on the bottom away. And so whatever 6 times tangent of 18 is, so it's calculator time, y'all. And then I'm going to have to double it because this is half side. So when I'm typing this in on my iPhone, I have to type it in backwards. So 18 tangent times 6. And then I'm going to actually leave that in there because, and I can write it down right here, but now I'm going to want to double it to get the full side. So I'm just going to leave that whole decimal there so I don't round yet, and then times by 2. So the side is approximately 3.89. And honestly, I'm going to leave that on my calculator as well. Because when I think about finding the area now, half apothem, which was 6, times perimeter, which is going to be 10 times the side length, which is this number that I have saved on my calculator. Now I feel like because I'm just going to multiply all these things, leaving this number in here was really wise to do because I don't have to round. So I'm going to take this, I'm going to times by 10. Oop, it's behind my face. There we go. Then I'm going to times by 6. And then I'm going to take half, so divide by 2. And then I have like kind of the least rounded area because I kept all the decimals in here. I didn't ever write it down and then type it back in with chopping a whole bunch of those numbers off. So we got 116.97 feet squared. Alrighty, let's try another one without a picture. Find the area of a regular octagon with a side length of 6. So I'm not very good at drawing octagons, but drawing a right triangle is no problem. And I know I drew it the other way, but I just wanted you to see, like, it doesn't matter which way your right triangle's facing. The side going up and down is always my apothem. The side on the bottom is always my half side. And the hypotenuse or diagonal side is always your radius. We're probably going to have to find that central angle. So now we just want to label what they've given us. So we have a side length of 6. So like this whole thing is 6, meaning that half of it is 3. And then unfortunately they don't tell me the apothem, so I'm going to have to find that central angle, but at least they didn't give me the radius, which is completely useless information. So to find my central angle, we're going to do 360 divided by 8, which I feel like we did this one earlier on this page. Yeah, that was the nasty one. So, oh no, it wasn't actually that bad. 45 degrees and then split in half is 22.5 degrees. There was that one that we did in class the other day where it was like a super yucky decimal. I think the 7, yeah, the heptagon. That one super sucked. This one is 22.5, so I'm going to leave it 22.5. And because I have one of the sides that I need, and I have to find the other, that tells me that I'm going to have to use tangent. So to find my apothem, we're going to use tangent of the angle. So looking at this angle, tangent is opposite over adjacent. So opposite of this is 3. The adjacent is the apothem. And when my unknown is under, this is where we do the little swappy swap. So we get A equals 3 over the tangent of 22.5. And now it's calculator time. So I'm going to type in 3 divided by 22.5 tangent. So that's how much the tangent is. Now I have to hit equals to get the division. So that is the length of my apothem. And just like I did on this last one, I mean, I can write it down, but I'm going to leave it on my calculator to not chop off that whole decimal. Because since I think I have everything else to find the area, I can just leave this number in there. So to find the area of my octagon, I'm going to do half apothem, which is this number here, times perimeter. Oh, excuse me. Which the perimeter is going to be 8 because we're an octagon, times 6 because the side is 6. So I can kind of just go do all that right now. So I can take my apothem and divide it by 2, like take half. Then I'm going to multiply by 8. And then I'm going to multiply by 6. You can kind of go in any order there. So that's why I did it in kind of a weirder way. So area is approximately, and now I'm going to have to round, 173.82 centimeters squared. And then last but not least, so my guess is this one is going to be radius because we had apothem, we had side, and now I'm going to have to figure out both. A scratchy throat. All right, so find the area of a regular dodecagon, that's 12 sides, with a radius of 20, of course. So I definitely cannot draw a dodecagon, but I don't need it. I really just need the baby right triangle, where straight up and down is my apothem. Flat on the bottom is half my side. And then hypotenuse side or diagonal is the radius, which in this case they did tell me was 20 inches. So it kind of sucks because I have to find both the apothem and the side length. Before I do, I have to find that central angle. So we're going to do 360 divided by 12 and then divided by 2. So kind of just divided by 24. Because if I divide by 12 and divide by 2, I really divided by both. So that's 24. So 360 divided by 24 is 15 degrees. So a real small angle here, which makes sense because it's a real big shape. So it got split up a lot. And then if you remember the time I did this before, when I had to find both, I had to use sine and cosine. So I'm going to have to make a choice which thing I want to find first. Maybe I'm going to find the side first. It really doesn't matter. I don't know why I went with that. But if I want to find the half side first, that is opposite your 15 degrees. And then the side that you know is the radius, aka the hypotenuse. So opposite hypotenuse is sine. And it's kind of cute, like, again, when you have to find both the side and the radius, or side and apothem rather, to find the side, you always use sine, side, sine. Kind of nice. So sine of 15 degrees equals the opposite side, I do not know, over the hypotenuse, which is 20. When x is in the numerator, I'm just going to multiply the 20 over. And so my approximate half side here is going to be 15 sine times 20. So 5.17. Oof. Now, that is only half, so now I got to double it. And so the full side length is 10.35. Now, the real struggle here is because I'm going to have to use trig again. I personally can't really keep this on my iPhone calculator. If you're using like a better calculator, you might be able to keep it all in one spot. But I kind of had to delete that because now I have to go find the apothem. And that's going to require a different trig function. So to find the apothem, looking back at my right triangle right here, the apothem is adjacent to my central angle. And the side that I know is 100% correct is the hypotenuse still. So we're going to use cosine. And I don't know if it's as cute, but because cosine is adjacent apothem is maybe a way to remember. You're always going to use cosine to find the apothem when you're finding both. If you only have to find one or the other, you're always using tangent. So cosine of 15 degrees equals the adjacent side of the apothem over the hypotenuse 20. So it's really identical to the last problem. I'm going to multiply that 20 over. And so my approximate apothem is going to be 15 cosine times 20. So 19. I don't need to double this one because it's the apothem. We double the other because we need the full side, not half the side. Okay, so now I have all the information. We can find our area by doing half the apothem, so that 19.32 times the perimeter, which is going to be 12 times the 10.35. Because there are 12 sides, and each one is 10.35 units long. So let's get this real gross approximated answer right here. I'm going to take half of 12, so just 6 times 10.35 times 19.32. Dang, that's a lot of area. I feel like they told me the units on this. Yeah, inches squared. All right, guys, hopefully that helped if you're struggling still a little bit, and I'll see you in the next one.